Bom, 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 bom. Dit is niet wat het lijkt op het eerste gezicht. Bom, 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 bom. Dit is geen Nerdland, maar een overzicht. Bom, 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 bom. Maar wel een gratis extra aflevering. Dit is een Nerdland special. Een aanvulling.
Met uw gastheer Lieven, Scheire.
Oh yeah.
A good day, everyone. Welcome to another episode of the Nerdland podcast. We have a special guest, and we try not to be too starstruck, because with us today is Randall Monroe, known from the XKCD podcast and a few books. We will talk about your books during this podcast, and of course about all the other things that you do, and hopefully all your geeky interests. Welcome, Randall.
Hey, thanks so much for having me.
It's an honor. It's an honor, but I will stop all this geek fandom now so we can have a normal conversation. Let's introduce the people who are here. So we are the Nerdland podcast. Every month we get it together and we look at the science news of the past month, the quirky news and the interesting news. And then we have with us Natha. Natha studied electromechanics and is now working in software. We have Jeroen. Jeroen is a computer scientist, and he studied computer graphics in video games. So walking through a video game with him is very interesting.
Very tedious, yeah.
He only talks about pixels and vision lines and light rays and things like that. Next to me is Bart van Peer, a physicist, just studied physics. I studied physics. You studied physics too, I think?
Yes, I have an undergraduate degree.
Okay. And then we have Stephanie. Stephanie is an illustrator for science books, for children's books. And a few months ago, she did the illustrations of a book with children's questions. So that's already a connection we have there. Because the thing we're going to talk about today, we're going to start with, is the Dutch translation of your new book, What If 2 in English, Wat als 2 in Dutch. The second one, What If 1 was 6 years ago, 8 years ago?
Something like that, yeah.
Yeah, a few years ago. But you had enough crazy questions, because that, of course, is the concept of the book. People send you absurd, hypothetical questions. But the amazing thing is that your research is so thorough and leads you to unexpected places that they become very interesting stories.
Yeah. And what I was surprised was, after I did my first book, where I answered people's questions, one of the consequences that I didn't anticipate was that parents have kids who ask them questions. You know, they'll say, why is the sky blue? And you say, oh, it's because of this, science effect. And they'll be like, well, why does that happen? And then you say, oh, well, I don't know. That's sort of a quantum mechanics question. So, you very quickly, when you get asked questions by little kids, if they keep asking why, you run into something, no matter who you are, you'll run into something you don't know the answer to. And what I didn't expect was parents who read my books then would have kids of their own who start asking them questions. And when they hit the point where they couldn't answer, they would be like, well, why don't I send it to the what if guy? And so I suddenly became a resource for parents to pass on their kids' impossible science questions.
Well, so the exact thing that you are telling us now is something that in Belgium it has been turned into a website called, well, so it translates as I have a question.be, and it's science communicators, and the purpose is if parents have children with interesting questions, then they can send it there and professors can answer it. And that's what Stephanie made the book about. So they took the most interesting questions. Stephanie did the illustrations. And you had a remark, Stephanie, about the ideal age of children's questions.
Yeah. Yeah, so I illustrated 2 of these books. And I noticed there seems to be like a golden zone or a golden age, golden age range for awesome questions. And I situated, in my experience, between 6 and 9. Does that sound familiar to you? Like that is the age where you get the best questions?
Yeah, that seems right. It's sort of funny for me because I didn't set out to solicit questions from kids. I was just thinking, I'm just going to answer questions I'm curious about. And then I meet all these people who are like, oh, yeah, I got your book and my, 9-year-old loves it. And I was like, oh, I guess it would appeal to a 9-year-old too. That wasn't really what I had in mind. I was just thinking like, I'm curious. But it turns out kids are curious too. So, I don't have as big a sample probably of specifically kid questions. I mean, occasionally I'll get a question, someone won't even say their age, and then I'll learn, oh, this is actually an 11-year-old.
Have you kept that in mind for the second book, that there is a child audience for this book? Of course, with Thing Explainer, it is obviously like the language is easier. But when writing What If 2, did you keep that in the back of your head, that there was a younger audience for these books or not?
Yeah, maybe for the people who don't know Thing Explainer. So Thing Explainer is another book of yours where you explain scientific and technological things with the 1,000 most used words in English. So yes, go on, please.
Yeah, I definitely thought about it. But whenever I'm writing my explanations, I always just sort of think about writing a note to myself, before I understood the thing. So I don't try to think like, how do I explain this to someone who is this old, or is this, I just think like, well, what was it like when I didn't understand this? What would I want myself to know? And sometimes that means I'm imagining little kid me. Sometimes it means I'm imagining myself 20 minutes ago before I learned the thing. But yeah, I think that what you're saying about age is really interesting and on the mark, because definitely some of my favorite questions come from little kids around that age. There's even at least one or two from like 5-year-olds that are really good. And I think it's because at that age, the kids are not as self-conscious about what they know and what they don't know, and they're not trying to come up with a science question that shows their impressive understanding. They're not trying to impress you. They're just asking a straightforward question that they want to know the answer to, and like very often it's a question that is easy to answer that everyone knows, but then sometimes it's not, and that's when it makes for a really interesting science question. I found that kids in 7th and 8th grade, I think, asked the most alarming questions.
Alarming ones. Oh.
Just questions where, like, one of the ones that I included, I got a couple of questions from like middle school chemistry classes. So these would be like, I guess, 12-year-olds, 13-year-olds. One of them was sent in on behalf of a whole chemistry class. With just the teacher's name attached, but said, what would happen if you connected a tube into your stomach and then you just pumped pure ammonia into it?
Oh.
What would it release heat? What would the gas do? What would the ammonia, what would the consequences be for the person? And I was like, what is going on in this science class? But
you would
also
be put on some kind of list, definitely.
Yeah, definitely. But I realized, I don't actually know. Like, I'm sure that would be bad, but I don't know what would happen. And then and chemistry is tricky and interesting. And so I got to get in touch with an experimental chemist I know and like work through the consequences and figure out what exactly would happen. Because it wasn't sort of what they expected, but it turned out to be just as bad and just as bad an idea to try.
You've got an entire chapter of disturbing questions, 2 chapters of disturbing questions in the What If book. Can you stick your arm out of a driving vehicle and smash a mailbox off its pole without breaking your hand? Of course. And also you have short answers, a few very short answers, and I've noticed that many of them are simply don't. Because there's this one question that I also was really... Was I alarmed? Probably amused, but somebody asked you what would happen if you would take your eye out of the socket and then turn it around to look at your other eye.
Yes, I feel like I wanted to discourage. I don't think the person who asked that was planning to actually try this. I have a disclaimer in the front of my book that says like the author of this book is an internet cartoonist with a physics background, not a safety expert. He, likes it when things catch fire and explode. So he does not have your best interest in mind. Do not try anything in this book. But like a lot of the stuff in the book, I think you couldn't very easily try. Things involving like walking on the sun. Someone asked how much sunscreen it would take to protect you if you wanted to visit the surface of the sun. And like, I'm not worried that my readers are going to go try that. And then there's this question.
Yeah, you've got other problems.
Yeah. Well, but then there's the eyeball question where I'm like, that's just such a strange idea. Like, obviously you wouldn't want to do that and it wouldn't work. But, just hypothetically, what would you see? That became I was like, it's gross, but I'm also very curious. Like, what would it look like? And so I tried to figure it out, because I sort of imagined that it would be something like, like if you point a camera at the screen that's showing the view of the camera and you get like an infinite loop. Yeah. It sort of seemed like, would something like that happen? But it turns out, no, you would just sort of see double. You'd see two eyeballs overlapped. And then probably you would see people rushing in to be like, what are you doing? Stop that.
Your own wounded face and very disturbed people all around you.
Yeah.
What I think is so appealing to the What If books, the first one and now the second one, is that the research is so thorough and you never dumb it down. That's something else. Also with the children's question, people think they have to talk to children in very easy words. They're really interested. They want to know. And also here, the depth to which you take very simple questions. I read one and it took me back to my physics classes. The very simple question: how big a lens do you need to make fire with moonlight? So we've done it with the sun, with the small magnifying glass, and then there's also light coming from the moon. How big a lens would you need? And you kind of end up in thorough thermodynamics to explain why it can't work.
Yeah, and I think that is maybe the most difficult to answer question in the whole book, just from a sort of physics complexity point of view. Like, that's an idea that it took me a lot of reading just to understand why you can't focus moonlight down into a point to make a fire. Because it just seems like it should work. And the reason it doesn't work is sort of very abstract and very mathematical. And it's like, I still get letters from people who are telling me my explanation is wrong. And they have diagrams showing, here's, I'm a physicist, here's why this isn't incorrect. And like, and to this day, I think that's the thing I get mail about the most, like, of stuff that I've published. I put up a version of that on my blog and people started writing to me right away. And they've never stopped. People want to argue about that one. And my explanation for why this won't work is right. But it's like, it's not just how would you explain this to a kid. I don't know how to explain this to a physicist.
That's also something that I notice a lot in your XKCD cartoons and in the What If book. One of my favorite answers to science questions, especially when children ask them, is nobody knows. There's so much stuff that sounds really simple. And then you have to tell people nobody knows why we make a laughing sound when things are funny, or why we yawn, or we're not even sure why ice is slippery, or why lightning happens.
Have we solved how airplanes fly? Wasn't that one of the ones as well where nobody could really explain it?
I think it was explained in your book, right?
Yeah, I think we have a pretty good handle on how airplanes fly, and the question is more like what abstraction explains it, captures the equations the best. But like, we understand the equations. It's very straight. Like we know how the air moves over a wing.
A really fun thing to do is walk into a room where there are several pilots or engineers and ask them to explain what the role of Bernoulli's law is in airplane flight, and you will get a huge fight between them because nobody seems to agree.
You better run.
Yeah, absolutely. And then there's like the question about the airplane on a treadmill. All kinds of fun.
There was also somebody asked you if you could save energy by launching an airplane instead of letting it take off by itself on kerosene.
Yeah.
Anything useful come out of it?
There have been some proposals. It would save a little bit of energy, but not all that much. The advantage would be you could power the plane during its takeoff using some kind of clean energy, because burning jet fuel is very bad for the environment. And so if you can use an electric catapult, a sling to like accelerate it down the runway, that you could save some fuel, but it would end up not being all that much. It would be, because the takeoff is a very brief period, even though you do burn a lot of fuel. So, you might save a few tens of gallons, but not it wouldn't make a significant dent in the overall flight. And it
makes me think about that spin launch project that like you see pop up from time to time, where they basically use like a big swing to like launch things into space, and like the energy like breakdown is basically it's not worth it, and everything inside is going to be liquefied. So yeah,
I've seen that. There seems like there are a lot of people who have put money into that project. Yeah. So I maybe they know something I don't about spinning objects.
Well, if a lot of people putting a lot of money in it was a sign for something useful, then cryptocurrency and NFTs would be very useful. So.
Don't get us started, Lieven. We've only got an hour.
I'm very interested in the research because one of these questions pops up. Let's take. I think it was the original what if question. What happens if you throw a baseball close to the speed of light? I think was one of the first ones that you tackled.
Yep.
How is your research process? I'm just wondering what makes a good researcher. What do you do the moment this question ends up in your head or in your mailbox?
I'm not sure there's now that's a hard question. So what I pick when I pick out a question I want to answer, it's usually because it's a question where I don't know what the answer is, but I really want to know. And so I'll pick something that I am curious about. And sometimes I'll have a guess about what the answer is. And I want to figure out, okay, if that's true, how can I prove it? But then it's sort of like I am trying to think of anything that would work. So like I'll just say, okay, this is sort of similar to this, engineering problem. I can go find papers on that problem and see how they've solved that, or like maybe the solution is this, which would also have this consequence. So I just need to go look up if that's true. And then sometimes it'll be like, well, I don't know how this substance behaves. I need to go find out what are its basic properties. And then I'll go look up, papers on that substance, materials, safety data sheets, etc. But like, I sort of come up with an idea that seems like something I could figure out, and then go to try to figure it out. But I think it's sort of similar to the problem in science of like hypothesis generation, which the way you test a hypothesis about how an experiment will come out is very that's sort of like well studied in statistics. It's sort of like a very constrained, it's clear what the problem is there, what you need to do. But the question of how to come up with the hypothesis in the first place is like, well, you just kind of think about it and guess. And I feel like a lot of it is just trying to come up with ideas for what might happen and figure out which ones I have a way of proving. So yeah, I'll draw on a lot of research. I'll go and look up papers. I'll go and just, Google like what companies have tried doing this, what experiments have tried doing this. Occasionally I get really good data. There'll be something that I'm trying to study and I can't find any scientific research on it, but then I find that people on YouTube have gathered data. Like there's these
there's Nature, Cell, and then there's YouTube.
Well, there's these Australian like 20-somethings who throw heavy objects off of dams and off of bridges like film what happens when they hit the ground. And like it's hard to find scientific papers on like what happens when a giant water balloon, like a sphere of water hits like a table, like a normal table, or like the roof of a car or something like that. And you can spend a lot of time in automotive modeling studies and looking at the roof. But if you want to figure out how the roof of the car will respond to an impact of an object of a given size, maybe you can find someone on YouTube who has tried it.
So we're probably not that far away from a Nobel Prize for a YouTube video.
yeah, who knows? Could happen. Do you ever experiment, or is it pure looking up things and calculations?
I almost feel like I only do experiments as a very last resort. Also, occasionally when I realized that experimenting would be much easier than what I was doing. So like there was one time when I was trying to figure out what the density of various common types of candy were. Like how much denser than water? Are they much denser than water, or are any of them less dense than water? And I was like reading, but it's like if you look at like food science journals, they're not really talking about like if you go buy an M&M, does it float? You know, and it like it's hard. That data exists, but it's hard to find. And I was spending a while like, okay, well, the bulk density of sugar from this resource is this, but from this resource is this. And I don't know what additives go into these kinds of candy and how they change the density. And then I suddenly realized I could just go and get a glass of water and some candy and drop it in and look and see, oh, yeah, it's more than 1 kilogram per liter, you know.
Ooh, that's a step too far for me. I wouldn't,
when does a question get discarded? Sorry, like a tiny... Because all of the answers in your books are entertaining. When you're researching a question and you're formulating an answer, do you sometimes say, okay, I've got the answer, but it's not entertaining enough for the book? What's your decision process there? So when I'm going through questions to, you know, maybe answer them, like going through the inbox of people who've emailed me, there are a lot of questions that someone asks where I can do a calculation to figure it out. But then the calculation is not that exciting. And it's like easy. Like I you know, open up Mathematica and just do a calculation and like, oh, here's the answer. You know, like could all the deer in the world stretch from one end of North America to another, you know? And like, okay, got to go look up, you know, what are the deer population estimates? How long are they? Like, what's the age range? You know, whatever. And like, but I'll do the calculation, and like even a very cursory calculation, it's clear, oh yeah, they would or wouldn't stretch across the country. And then it doesn't feel like there's that much more there. Like, I'm like, okay, I'm satisfied. I don't know anything more I'm curious about now, you know? And then I just move on without ever writing anything down about it, you know? And so there are a lot of questions where, so what I'll do is more, I will try to answer the question to my own satisfaction or until I'm no longer curious. Like I decide, oh, this question doesn't really have a well-defined answer. And then I sort of think like, have I learned anything that I am excited to go tell people, you know? Like,
yeah, that's a good rule of thumb in science communication. I think that if you want to go to a friend or go to a pub and tell people about what you found out, that's always a good sign.
Yeah, and if you know, like they've asked the question, so they want to know the answer, but like the answer itself might be really simple. You know, it's like how many you know people would it take to tip over the Washington Monument by pulling on it with cables? And you could say like, oh, it's 750 people or something. But then you're like, well, if I told them that, they would be like,
okay,
you know,
yeah.
How do you know that? Yeah. What do you mean? How would it break? You know, would it tip over would the top come off, or would the whole monument tip over? You know, and I'm like, oh, I would probably have those questions too. I want to include those in my answer. Yeah. You know.
Now, the things that you write are, of course, very popular in the geek community and so reach a lot of scientists. Other people must have experimented with some of your what-if questions. Did any of these experiments, did you hear of anybody experimenting with one of these things? Yeah.
I'm always surprised the things people manage to try. So I did in my first book, I had a question about... Someone asked, how high would you have to drop a raw steak for it to be perfectly cooked when it reached the ground?
Because of the friction or the...
Yeah, well, and so if you drop something high enough and when it comes into the Earth's atmosphere, it's going so fast that it compresses the air and heats up, and then the leading edge of it will get heated by the plasma, you know. And this is why meteors glow and why spaceships...
A shooting steak.
Yeah, exactly.
I wonder if you can do a wish when you see a shooting steak.
As long as you're wishing for some kind of dinner.
You can only ask for more meat.
And did somebody drop the steak from the International Space Station, or what happened?
Well, what was interesting was when I answered this question, I answered it in my first book, and I said, okay, it's actually pretty easy to calculate how the steak will accelerate as it falls. And it's pretty easy to calculate, you know, from a physics point of view, like how hot it will get from the air compressing in front of it, until it reaches, it'll go faster, 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 reach the thinner layers of Earth's atmosphere, and then slow down. And so for a little while there, it'll be reaching high speeds and a lot of heat. And so I calculated all of that. I actually had a fun moment where I was trying to figure out, I knew from aerodynamic calculations roughly how much heat would be applied to the front of the steak, but I didn't know how quickly the heat would travel through the steak to heat the interior. And I was reading these okay, what are the thermal conductivities of I guess raw meat, but I was looking in engineering textbooks where it's they have thermal conductivities of aluminum and foam and wood. And I'm but there's no meat here. Oh, maybe industrial food processing journals will have this. And then at some point it clicked. I realized there is an entirely different field devoted to studying what happens to a steak when you apply a certain amount of heat to one side of it, which is cooking. And so I just went and got a cookbook and looked it up there. But when I published my answer, the one thing I wasn't sure about was the way the steak would tumble and flutter in the air and how that might affect its mechanical properties. I know that when things fall at hypersonic speeds, they tend to sort of present their highest friction face. But I didn't know if the edge of so I thought that the steak would sort of fall flat side first, but I didn't know if the edges would ripple and would it shake itself apart? Would it flutter? Would it tumble? And I said, that's a hard problem. So I don't have any data on this or any studies, but I put a footnote sort of as a joke. I said, if you have access to a hypersonic wind tunnel and want to do some experiments, I'd love to have that data.
Throw a steak in there.
Yeah. And so 2 years
someone did?
Yeah. So a couple of years later, I heard from these two PhD students from, I think, the University of Manchester, who said, "Hey, we just finished our dissertation work on blunt bodies at Mach whatever, high hypersonic speeds, and we had some time left over on the wind tunnel. So one of us went to the corner store and got a steak, and we strapped it up in the middle of the wind tunnel and tried exposing it to hypersonic winds."
Did they eat it afterwards?
No. Well, so I felt like I was quantitatively vindicated about the numbers. The heat was similar to what I described, and it burned and ablated the exterior, the surface of the steak, but the interior didn't actually get hot. So it wasn't very well cooked. What I think I didn't appreciate, they sent me a few pictures of the wind tunnel after the experiment was over.
Oh.
And
Wow.
And I didn't appreciate how unappetizing a steak would look after it had been heated by hypersonic winds. It was cooked, but it wasn't cooked in the nice, grill marks, brown surface. It was more it was like you had put it in a clothes dryer and turned it on high, and it was very ragged with lots of bits hanging off, and it looked like someone had rubbed it on the carpet or something.
Nothing a little sauce can't fix.
Okay, but now I want to try to put a steak in my clothes dryer because I want to see what happens.
You can probably...
I feel a new question coming up for a new book.
I think I did a chart once of using your toaster, your washing machine, your dryer, your dishwasher, and your oven. Which of these household tasks can you do? And there were a few of them that I wasn't sure about. Apparently you can cook fish in a dishwasher.
Yeah, I did.
Wow.
Yeah, you've done that?
Yeah, I did that once. It's the ideal temperature for salmon. So you can just put salmon au papillon in this aluminum foil, and then you can put it in a dishwasher, and it is ideal.
Our national COVID specialist, that's his favorite. One of his favorite dishes is salmon in the dishwasher. He demonstrated that on some program.
And is it with the dish tablet or?
Well, you can put a little bit of bouillon in the.
Extra flavor.
have all the salt and everything in there.
You're already struggling. We're already struggling to discourage kids from eating the Tide Pods.
Or we can make them healthy and tasty and add vitamin C to them, then they can eat them, of course. But,
I think you could do scrambled eggs in a dryer if you had a good dryer bag.
Okay.
I mean, they'd be tumbled eggs, but...
Well, my nephew and neighbor who lives there next to this shed. He had a TV show where they tried all this crazy stuff, and so they built a sauna with toasters to see how hot it would get. They tried to do the dishes in a car wash by just putting them all on the roof of the car, and then
how did it work?
It did not. This would have been one of your answers, saying just don't. They also went skiing on the stairs. They had some fake snow on the stairs, and then they put on a firework indoors, which was fun, with a lot of glass to protect them, and then they had a big firework there. Natha was wondering if you had questions that were so weird and creepy.
Yeah, because we talked about questions that didn't make the book, so I was wondering, are there questions that you don't even want to begin answering, like because they're creepy or upsetting, or...
I don't know. A lot of people have asked questions about... There are a lot of questions about, people will learn about, the Air Force One or the Pentagon have these protective measures, but could you get past them by doing this? and I'm like, you can go read Tom Clancy or whatever if you want to read about someone experimenting with that, but I don't really want to publish my ideas for really creative ways to commit terrorist attacks.
What if you stormed the Capitol?
Yeah, exactly.
Every question that begins with "Could you dispose of a body with?"
Yeah. And then there's there are a lot of questions that are sort of like medical advice questions almost. Where one way or another it sort of comes down to would you be healthier if you did this instead of that? Yeah. Where it really involves weighing in on kind of unanswered medical questions. Where I'm I don't need to be a wellness guru here. I really don't know the answers.
There's a lot of money in crappy medical advice, though. It's,
with our podcast, we could make millions, because we say in the podcast, when the COVID was in its heydays, we said we don't give medical advice, and we had people emailing, "I know you don't give medical advice, but," and then 20 paragraphs of medical data, and it was, we could have made so much money.
I remember 6 years ago we had I talked to you in Amsterdam in the Netherlands, and I asked you about the time that you were at NASA. You were working at NASA on a virtual reality project. I think I remember, and I remember one sentence that you tried to put things beyond infinity at NASA, which is some of the coolest job titles ever. And I can now see from the looks of my colleague podcasters here that they are very confused. What did you do how did you fumble with infinity?
That's an extremely exciting sounding way to describe a very mundane experiment. So I really appreciate that, because I'm going to steal that from now on.
There.
No, what I was doing was I was experimenting with, when you project a 3D image, you have to give two different viewpoints to the two different eyes. So if you have a screen, you want to have the thing the left eye will see overlaid with the thing the right eye will see. And if you have them directly over top of each other, then your depth perception will tell you that the thing is exactly as far away as the screen. And if you have the thing on that your right eye is seeing and the left eye is seeing, if you separate them so they are in line with your eyes, so your eyes are both looking straight forward, so they're one eye width apart on the screen, it makes it look like the thing is at infinity.
That's how we look at stars. So stars are so far away, but when you hold a pen in front of your nose, then your eyes make an angle to look at.
Yeah, so you cross your eyes to see close things, and you move them straight out to see things that are far away. And farther away than about, I think it's around 200 meters or so, your eyes don't, have to you don't have to move them at all. They're
so infinity is pretty close.
Yeah, infinity is pretty close. And so what I was thinking was, okay, well, wait a minute. If something's 6 inches away, your eyes go inward. And then if you move them further and further apart, and when they are pointing straight forward, that's infinity. What happens if you keep moving them further apart? And because normally there's nothing in nature that makes us need to do this. So for most people, your eyes just never go this way. But there's no mechanical reason they can't. Like, each eye is controlled by its own set of, you have your own set of muscles. They're not, like, physically tied together. And, like, you can look to the left, you can look to the right. And so there's no reason you couldn't direct your eyes in the two different directions. Your brain just isn't set up to send those signals. The muscles, the nerves that control it are not set up for that. But I was in this virtual reality thing, and I was like, okay, I'm just going to put the two images up on the screen, look at them. It looked normal, looks like something is pretty far away. So then I moved it out to infinity, meaning moving the two images apart. And then I just moved it a little bit past, and I could still focus. My eyes were a little bit apart. And then I moved it a little bit farther, and it was still in focus, but my eyes started feeling weird. Like the muscles were straining a little bit. And then I moved it a little bit farther, and suddenly, ow! It snapped out of focus and double vision. And I had to blink a few times and then focus normally again. But it was fun.
Hurt? Did the muscles hurt for doing something unusual?
Yeah, I think it felt sort of like when you try to cross your eyes too far, or like,
okay,
yeah. It just was like I'm sort of straining a little bit in a way that I wasn't used to.
And that was a research for NASA? Because it sounds very biological. Like, what was NASA doing with it?
I did a summer internship before I started working at a lab. And the project I worked on was a 3D, this was sort of before the Oculus type systems. So it was a 3D cave, meaning a set of screens and projectors around you that you stand in the middle of wearing shutter glasses. And it projects 3D stuff all around you. And so they were trying to build a nice portable one of these to demo, like, here's our Mars robot. Here's here's the view you'd get flying. There was people down the hall were working on the Ares project, which was then canceled, which was a Mars airplane. And so our demo was like using this 3D system to let you look at a model of Mars and the airplane, and somewhere in between demos or just cool visualization tools. So I was just messing around with the code that ran the 3D system. And so I just started getting curious. Wait a minute, what happens if you move this? If you drag this slider past this point?
What if?
So I was just sort of did that for my own curiosity.
Then you got fired because everyone got headaches.
No one else wanted to look. I was like, hey, check out this weird thing you can do to your eyes, and people were like, what are you talking about?
Come on. So people at NASA don't want to look past infinity. My God, man, it's amazing.
Yeah,
to infinity and beyond.
I think that one other person in the lab with me did think it was cool. I don't actually remember, but it wasn't useful for anything. It wasn't important. It was just kind of like, oh, that looks neat, but it kind of hurts.
I would wonder too. Well, if I could get the idea, because first you have to get the what if idea. What would happen if I moved my eyes further apart than that? That's probably the inspirational and the hypothesis part that we already talked about.
Yeah, well, because I had to program in the eye distance. So I was like, editing this variable, and I had measured my own eye distance, and so I knew where to put it. But then I was like, well, I can just change this number to anything. What happens if I put it past my eye distance?
Okay.
Yeah.
But it still felt like an object at infinity. It didn't do weird things with your spatial awareness of what you were looking at.
Yes, I think it did still look like an object at infinity, but it started... I should really try this again and see. I'm going off of my memory here of doing this once, Okay. But it still looked like an object at infinity, but I think everything else got a little bit out of focus. Everything else got a little bit double vision because I wasn't focused right on the non-virtual, the background around it, the scene in the room.
What we do in this podcast every month is looking back at science news, both the very important headlines and the small news that interests us most. You were active at NASA. Did you keep following the space things, the new space that is going on, and all the other geeky science news?
Absolutely, yeah. I've really enjoyed. A lot of the stuff NASA's done. They've done such cool kind of public outreach stuff and made it really easy to follow progress in their missions. And I feel like that's just as exciting to me, as it was when I was actually there, if not, even more so, like, because it's like all fun for me. I don't have to do any work. Yeah, and so I will stay up at night refreshing the website when they're going to land a probe on something. When I was on my book tour doing an event with Annie Rawerda of Depths of Wikipedia, who's really cool, and we were on stage when the NASA, the DART probe hit the asteroid. Oh, yeah. So backstage, we were sitting there looking on our phones, like watching the pictures as the dot looked like it's starting to get bigger, and then it's like, oh no, we have to go on stage now. And there was still T-minus, 20 minutes. So we went up on stage, and then partway through the event, as we did a conversation and took some questions. But then partway through the event, I was like, okay, normally, audience, I would not tell you to check your phones in the middle of an event or to shout things out from the audience. However, hey, so did the thing hit the thing? And then a whole bunch of people said, yeah. And it's like, oh, okay, are there pictures? Are they cool? And they said, yeah, they're cool. And I was like, yes, okay, awesome. Because I just really wanted to know. So I had to interrupt the event.
Of course. I was watching the test launch of the Falcon Heavy with the car going to space. I was watching it on my phone under the desk of a live TV quiz that I was in. So we had set up this big night with our Nerdland listeners and community to watch it in a sports bar. So we took over a sports bar, all with screens with the launch, and then it was postponed a few hours, and I had to leave for the quiz. So I was while they were announcing the next question, I was like, oh my god, this is so beautiful! I wish I was there with the community.
How did you do on the quiz?
Not too good, I think, but well, they were not science questions, so I could afford to do bad. Now, what I was also wondering about is that a lot of the people that you probably follow in science or in space, a lot of them probably read XKCD or read the What If books. How do they ever reach out to you? Like what's the biggest celebrity or what was for you the biggest moment when somebody said something about XKCD or reached out to you? One of the science celebrities.
Well, I think I got a chance to interview Chris Hadfield, the commander of the International Space Station.
Yeah.
And that was so cool. It was so much fun. And I got to ask him a whole bunch of ridiculous questions that he was really game to answer. And he was just such a nice guy. Really exciting to talk to him about just thinking about weird space stuff. But it's really cool to be able to talk to someone who's actually been there,
Absolutely.
I think my favorite feedback I've gotten was he mentioned that he uses one of my analogies to explain how fast the space station goes.
Cool.
And I was like, oh, that's the biggest compliment that I can ever get, is an actual astronaut is you did a good job explaining space.
Wow. I think I remember that interview because there's one thing that I read there that he said in 30 years of astronaut interviews, nobody's ever asked me that question. I think it must have been great for him because as an astronaut, you probably get a lot of the same questions again. But then with your crazy hypothetical mind, he probably got a bunch of questions that he never had before.
Oh, well, it's cool. I mean, I do imagine, a lot of people, when they ask an astronaut, questions, I mean, if you're an astronaut, you probably get questions so what's it like being in space? That kind of, you probably, after you've answered that 100th time, you're like, no, ask me something, weird and boring. What do they fill the pillows with? Are they inflated? Do you have pillows? What are they for? Do you need...
and do they?
I don't know. Have you been to space? I haven't been to space.
There's nothing to lean.
Yeah, because I started to say pillows, but then I was like, well, you wouldn't need a pillow if you're floating in zero gravity. But I think they have zip-up sleeping bags. But maybe they have cushions for something, like maybe exercise or some kind of something where you get pressed against a surface. And are they full of?
I'm gonna have to look that up.
I think they get strapped in a bag. Yeah.
Yeah.
That's.
I think to keep extremities from.
That's a comforting thought that you would be strapped in instead of just because I also heard astronauts say that it's annoying that their arms just float around, that they don't just hang down, and they're always in the way. in the way.
Yeah, you have to put muscle power into that.
Yeah, probably to.
I'm here in Earth's gravity, and I still can't figure out what to do with my arms while I'm like.
Well, it's something that in geeky culture, people often have too many arms and don't really know where to.
We all have trouble with our extremities. Yeah.
Do you have time to kind of connect with the geek audience? Every year we have our Nerdland festival. Very welcome if you're ever in Belgium at the end of the month May. Please be our guest. So we have our Nerdland festival, which is just 2 days of festival with a lot of talks, science talks, demos, things like that. And that's where you're together as a community. Now you have a huge community of fans. Do you get to meet them or reach out to them?
Yeah, that's one of the really fun things about doing a book is, being able to go on tour and like meet a bunch of the people who have been reading it. Because like when you write a book, you're just kind of sitting in your room working on something, and you're like, oh, I've written all this stuff, but it doesn't seem real until you go out there and meet people who are like, oh, I read that, and here's my opinion, or here's my I studied this subject, and so it's always fun, especially meeting like there are always, people with kids, but then meeting scientists who are studying something that I've just been reading a paper about and like I'm excited about. I know I once met a radio astronomer. Like I met someone who's like, oh, I'm an astronomer. And I asked her what kind of astronomy? And she was like, oh, I study, radio astronomy. And I was like, oh, well, what do you study? And she said, compact objects. I wrote some papers on fast radio bursts. And I was like, oh, that's really exciting. I like just 2 days ago read this paper on fast radio bursts, and it had this cool thing in it. It was by so-and-so. And she was like, oh, I'm so-and-so. It's good to meet you.
Really?
And I was like, that is the weirdest, small world kind of thing. But I was really excited because then I got to ask lots of radio astronomy questions.
Yeah, there's a friend of our podcast who could not make it, who could not call in, but she really wanted to because her research was mentioned in one of your XKCD cartoons, I think last month.
Oh, which one?
You did the chart with how easy does it sound to find something out, and how easy is it actually? And I think her research was in it sounds nearly impossible, but there has been recent progress. Do you know it from memory?
I'm trying to remember what I ended up putting in that top center. I think it was about the Mesozoic extension?
That's the
Bingo.
one.
Yeah.
Yes, the season. Yes.
Yeah, like what month did it happen? 65 million years ago. What time of year was it?
Spring.
Yeah, that's the thinking.
Yeah, and I remember when the cartoon appeared that her Twitter line exploded and that she put it on the top. So she was about to call in.
Did she work in the one? Because there's the one paper from the site in the sort of Wyoming, South Dakota, somewhere up there. There's one site there where they think they have actual tsunami deposits with fossils from a Seiche wave of some kind. And I've been wondering, I keep wanting to check, like, do we have a second piece of evidence about the time of year? Have we found anywhere else?
The one that she used was the fish that had died. And the reason that they're so sure that they died shortly after the event was that they had this little glass...
the impact spherules.
I think that's
they were
the
in the
only
gills.
site, though.
Yeah.
Okay.
Yeah,
and then because of the bone structure.
Yeah. I really want us to find one other, like there's got to be another tsunami deposit.
It's a
somewhere.
bit of a controversial site, I think.
I think it is, yeah. That's why I'm, it's sort of in that, like, there has been recent progress, but I feel like it's not totally settled. There was one other study that maybe pointed at a time of year, and I can't remember what it was.
Okay.
But yeah.
I can ask her. Yeah, I can ask her, and maybe if she has an answer, I can let you know in a strange way. We are running out of time, but I had two questions that I really wanted to ask.
Sure,
and
go for it.
they're probably short. Your XKCD cartoon, I think all the fans know the title text is always an extra, is always something new. And I'm just curious, how often do you have title text stress? How often do you feel the pressure like, oh my God, my title text has got it's got a name, so I have to live up to it?
Oh yeah, I mean, I try to, I will put off, posting a comic until I've come up with something funny there. Sometimes it takes a long time. Sometimes I just type it right away. I do always write the title text after I've finished the comic, because I don't want to, I assume, I know that lots of people know about it, but I don't assume that they are going to read it, So I try to make the comic so it will stand on its own, I've decided to post it, and then I come up with an extra joke.
Of course, and there's this tens of thousands of people who put XKCD cartoons on the door of their lab or put it in a keynote, and they can't
and they have
really
to
show
out screenshot the little mouse over, print that out, cut it out very carefully, and put it underneath on one side.
Yeah, we're hoping for the days where augmented reality glasses are everywhere, so we can just make the alt text just float over every XKCD cartoon that we see. And then, probably our final question is something that has been a constant in our podcast since the very beginning. There's two teams in the podcast. So we talk about the science news, about the technology news, and every month there's some Elon Musk thing going on, whether it's Starlink or Tesla or Neuralink or... And so we have two teams. We have a Team Musk and a Team Musk Skeptic. I'm Team Musk. Jeroen is leader of Musk Skeptic from the very beginning. He's like, is he such a genius? And he's talking crazy on Twitter again. Now I know it comes out of nowhere, but where would you stand on the spectrum?
The answer can be, I'm separating the man from his inventions. No, one answer, no nuance. This is not real life. No nuance, please.
So no nuance. Wait, no. Are you saying no nuance allowed, or
no? You can't. You can't say I really like his inventions, but the guy himself is obviously a total dirtbag. So you can't do that. That's too easy. You gotta land on one side of the fence.
Oh, I don't know. I think I'll count myself as a skeptic of anyone with that kind of position.
I'll take it.
We can send you a T-shirt, Randall.
Yeah, awesome.
Yeah, Musk Skeptic. We have the T-shirt. And what about, so apart from the binary thing, you have to choose, what about his technologies and inventions? Do you follow what he's doing?
Yeah, I think somewhat. Whenever there's a cool space, I think I'm really excited about space, and so and cool technology things, and so I follow all of those, and sometimes that's coming out of SpaceX, sometimes other places. I'll turn on any exciting rocket launch and watch those, and some of the things that they've done have been really cool.
Yeah. So you're also looking forward to Artemis 1, of course, which will hopefully happen at the end of November. I think it is planned now.
Yeah,
and then
definitely hoping.
Jinxed it again now.
Yeah. I mean, I didn't think the Webb telescope was ever going to launch. It just felt like it had been my whole adult life that had been being pushed back slowly. Further and further.
The agonizing days before it was completely unfolded, everyone who looked at the 3D animation of what was going to happen said, no way.
This is not going to work.
1 million kilometers from here.
And that's the thing that I feel like I really like that NASA does really well is throw a bunch of effort and energy toward something where you have no room to make a mistake. It has to work on the first try, and it takes a huge amount of resources for nothing other than satisfying our curiosity and teaching us about the universe. And the fact that they designed, funded, launched that telescope, and it opened on the first, it opened right, it all worked perfectly. That just boggles my mind. It's so impressive. It's such an achievement. It
really is. And the pictures that we're getting now, and just the science, conclusions not maybe, but the new insights it gave us in just a few weeks' time were already amazing. So hopefully a bright future ahead for the James Webb Telescope. Good. That is all we have time for. We're going to really, really thank you for making our week, possibly our month, by talking to us. So we were talking about your new book, What Else, with all the great answers to hypothetical and absurd questions. And of course, everyone can follow you on xkcd.com and all the other books. We'll put a list in our show notes. Thank you for being here, and enjoy the rest of the day because you have a day ahead. It's evening here. So.
Oh, well, thank you so much for having me. It was a lot of fun. It was good to meet you.
It really
all.
was for us. Okay. Thank you. Bye.
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 Bye.